Hello, welcome back to Piers Rocks. Today I'm going to try and resurrect this 2040 disk drive. So we've seen this 2040 disk drive on the channel a number of times, and it has been working in the past. I've confirmed that it's a DOS1 Commodore disk drive, and I've been on a bit of a learning curve myself to understand how to use these disk drives and how they differ from the DOS2 variants. Last time I went to use this disk drive for one of these videos, it turned out no longer to be working. It still boots, the lights come on briefly and then the lights go out. That suggests to me that the CPU is still working and the ROMs are still working just fine, but there's a problem with some of the circuitry that handles the I/O, because whenever I try and query the disk drive, get its status, or run any other commands, either from the PET or from one of the adapters I've got for my Linux PC, I get no response. So today I'm going to figure out why not. So to start with today, we're just going to take a look at the symptoms that this 2040 is showing us. On the screen in front of you, you can see I'm running my CLI for accessing Commodore disk drives on a Linux PC, and I've got this connected via an IEEE 488 variant XUM1541 adapter. First of all, I'll turn the disk drive on. So you saw the lights came on briefly and then went off again. That's entirely normal and expected behavior from the disk drive. Next, I'll show you what we see when we try and query the status without the disk drive attached. Right now, the disk drive is not yet attached to the XUM1541. So if I run the status command, I just get an error returning immediately. Now I'm going to plug in the disk drive. Now, today, you're actually going to see me wearing a wrist strap, which I don't normally wear, a grounding wrist strap. And that's partly because I have a nasty feeling I actually zapped one of the chips in here using static. And the other reason is because when I came into this room this morning, I noticed that I was really quite staticky, and I really don't want to zap any more chips on this disk drive. So I'm just connecting the parallel port, the IEEE 488 connector, up to my XUM1541. And then we'll run a status query again, and it just hangs. Just to confirm that a bus reset is working. That's totally expected. And then when we try and get the status of the device, our XUM1541 just hangs. So there's something wrong, I think, on the disk drive with the I/O handling. I've confirmed that this XUM1541 and the software works just fine with my 2031 IEEE 488 disk drive, so it does seem to be a problem with this disk drive. So the next thing we'll do is we'll take a quick look at this schematic for this drive. I've got the 2040 schematic open in front of us. There's 4 pages to this schematic. The first page here is focusing on the circuitry driving the read-write heads. We can see those in the top left-hand corner. We're not interested in those here. We're getting nowhere near the read-write heads. The next page is upside down. This is the page we want. We'll come back to it and turn it the right way up. The third page, we can see on the left-hand side, there's a 6504 processor. That's a pin-reduced version of the 6502. There's also a 6502 in this disk drive. This is focusing on motor control. Again, I'm not really interested in the motor control circuitry. And then this fourth page is looking at various other bits of circuitry, like write protect circuitry and so on. So if we go back to the second page, and I will just flip it around. Okay, so this is flipped around. We can see on the left-hand side we have the 6502. We have a couple of 6532 chips in the middle of the diagram. And then on the right-hand side we have the IEEE 488 connector. We can see the digital I/O lines, all 8 of them, because this is a parallel bus. And then we can see the IEEE 488 lines, like the attention line, the data available line, end of indication, not ready for data, can't remember what NDAC stands for, no data probably. And we can see that this is all being handled by the combination of the 6532 UC1 and the 6532 UE1, and then they talk to the 6502. I'm fairly sure that the 6502 is fine, given we're seeing the drive complete its boot sequence successfully. So I'm going to be concentrating my attention on the 6532 chips at this point and see what I can see. So we'll get the disk drive open on the bench in front of me. So I've got the unit powered up, connected up in front of me, and it's showing the same symptoms. So what we have inside here is we have the 6502 all the way over here, the ROM chips here, and then the bit I'm interested in is the circuitry here. So the IEEE 488 connector comes into the drive here, and then we have one of the 6532s there, one of the 6532s there, and then we have MC3446 IEEE 488 bus transceivers. We have one there, and one there. So most of the control lines come into this transceiver here and then over to this 6532, although the attention line comes in, I think, to this MC3446 chip and also goes directly to this 6532. First thing I want to check is whether any of these chips are getting particularly warm, and I am anti-staticked up. Now the warmest chip there is the 6502, but it's just slightly warm. Now I'm probably going to need to get the oscilloscope out to figure out what's going on. Before I do that, I'm actually going to swap the two 6532 chips over to make sure that the problem stays the same, and if the problem changes, then it strongly suggests to me that one of my 6532s has a fault. Just before I do that, I'm going to check the voltages on each of the chips. Alright, let's just check the voltages on each of the transceivers. So yeah, we get 5 volts on each of those. Let's take a look at the attention line. Pin 12 and pin 4 on UB2. This is UB2. So attention is currently high. It's active when low. Let's see if I can see that changing when I perform an activity on the bus. So I'll just reset the bus. See nothing. Did I see the drive reset? Yeah, the drive is resetting. Then let's do a status query. Oh, interesting. So attention has now gone low, which is active. And we could do a status query. So we actually got a failed status query that time, and obviously we saw attention line drive back to high. Let me reset the bus again. Yep, so we see attention pulled low, which is active, and then we run status and we see it go high. I've swapped the two chips around, and I've also marked on each chip where it originally came from. That was UC1, that was UE1, and now swapped around. I do have them in the correct orientation. The power is on. I'll reset the bus. So yeah, the drive has reset. Then let's do a status query. Same problem, I get an immediate error response. So I'll reset it again, and then we'll take a look at the attention line. So we see it low, do a status query, drives high and stays high. Do another one, no change. Alright, so we're seeing no change with the problem. So my immediate suspicion is with one of the bus transceivers, and that would make sense. If I'd accidentally put a bunch of static into the parallel port connector, chances are it would fry one of the 3446 chips, because they sit between most of the control lines and the 6532s. The only control line which goes directly into the 6532 is the attention line. That's why I was focusing on the attention line. So now I'm beginning to suspect the 3446s. Right, I've got the big guns out. Got the PET here. So I have the PET running a program on loop where it opens a channel to the disk drive. In fact, it does that only once. And then it sends a series of different characters to the disk drive. It sends 255, which is all ones. It sends 170, which is alternating bits. And it sends 85, which is alternating bits the other way around. And I'll show you the signals that I'm seeing on the disk drive. So first of all, we want to look at the attention line and make sure the attention line is being driven low by the controller. So the attention line comes into, I think it's pin 4 and 12, there we go, on each of the bus transceivers. So we can see there's activity there, it's being pulled low and then allowed to go high. And we should see that on all of the different transceivers, both on pins 4 and pins 12. If I can get a good contact, 9, 10, 11, 12. I think we should see it on 12 there. It's interesting that we're not seeing it on 12 there. Not seeing it on 12 there, but I am seeing it on pin. Let's get the right pin. Pin 4. Yeah, and then on this transceiver over here, just checking the program was still running. Well, I don't know why I'm not getting attention on all the chips. Oh, I see. So on UB1 and UB2, attention is connected to both pins 4 and 12, but not on pin UD2. Anyway, we're seeing a good attention line. We should then see the drive pull both the NDAC and NRFD lines to signal to the PET that it should send data. So looking at the schematic here, that's pins 6 and 10 on UD2. So pin 6 is this one, seeing activity there, and pin 10, we're seeing activity there. So once the PET detects that both of those two lines have been pulled low, it should then send data. And remember, we're sending different sequences of bits, but all of the different 8 I/O lines should be executed by this command. And the easiest place to probe all of the I/O lines coming in is actually on this 6532. So pins 8, 9, 10, 11, 12, 13, 14 and 15 have the DIO lines. So if I start at pin 8, that's pin 4, 5, 6, 7, 8. We should be seeing data on each of these lines. So that's pin 8, we're seeing data. Pin 9, data. Pin 10, data. Pin 11, data. Pin 12, stuck low. Pin 13, data. Pin 14, data. Pin 15, stuck high. So pins 12, pin 15 are DI4 and DI7, and they come to us from UB2. They are DI05 and DI08 from the bus. So they come in to pins 2 and pins 10. So we see on pin 2 on this chip, we see a signal coming in. So that's DI05 that we're not seeing it coming out on that pin of the transceiver. And then DI08 is pin 10. We're not even seeing a signal here, we're just seeing it always high. So this suggests to me the problem is either in this bus transceiver or this 6532. So it could be that this bus transceiver is broken and not sending through DIO5 and is always pulling DIO8 up to high. Or it could be the 6532 is essentially doing the same thing and is pulling the bus down and up respectively for those two pins. So a couple of ways I could test this. One, I could pull this 6532 out and I could bend the appropriate pins out so they're no longer connected to the MC3446. That will mean it can't pull the signals in either direction, and therefore we should see them operating correctly with those pins pulled out if it's the right chip, the 6532 chip. If the problem remains, then it's this bus transceiver. The other thing I could do is I could swap the 6532s back. Remember that I've already swapped them once and they're operating in the other position. I think I'll bend the pins out. That means I only have to pull one of these 6532s out. I'll bend the appropriate pins, that's pins 12 and 15, and then we'll see what we see on this bus transceiver. Right, I have those two pins pulled out. You can probably see them, these two pins right here are pulled out. I'm running the test program again. It's still going. So we'll double check the attention line and the NDAC and NRFD lines first. So we want pin 4. Yeah, seeing activity there. And then we want pin 6. Yep, still seeing activity there. And NRFD is pin 10. Still seeing activity there. That's good. So now we want pin 2 on UB2. Now we were seeing that signal before, but we weren't seeing it come out on pin 1. And we are still not seeing it come out on pin 1. Pin 3 is the input, so from the disk drive to the transceiver. Pin 1 should be from the PET to the disk drive. We're seeing nothing there. And then if we go and look at, what is it, pin 10 on UB2. We're seeing a signal there. We weren't seeing a signal there before. So that one has started working. Now the 6532 is no longer, the pin's no longer installed. But pin 1 isn't. So I don't quite know what to make of that. It definitely looks to me like this bus transceiver is broken, given the input on pin 2 simply isn't making it through to pin 1. So I think I have a broken MC3446. Right, it's the next day for me. I have removed the suspect MC3446 and replaced it with one from a 8050 drive. I don't know that it's good, but it's unlikely to have failed in precisely the same way. I've actually socketed the chip here. The socket doesn't seem a good fit for the chip, but I've kind of forced it in, so hopefully I'll get good connection on all of the pins. The other thing I did while I was working on this board was I touched up the parallel port, the IEEE 488 port connector on the underside of the board because it was looking pretty sketchy. It was a bit of a pig. Actually, working on this board was kind of alright, but working on the 8050 board was a bit of a pig. I ended up having to use both my desoldering pump and hot air to get the chip out, and I used a little bit of hot air on this one as well, just to make sure I didn't damage any traces when I pulled the chip out of the board. But I don't think any traces are lifted. We will now, I've got the PET running behind me, the disk drive's on and it booted fine. I've got my little program running on the PET to cycle between all ones and all zeros on all of the digital input output pins, and we will now probe each of them in turn and see what we see. So the suspect pins before were 2, DIO5, which we're seeing activity on, and that comes out on pin 1. We weren't seeing any activity before. If I can get good connection on this pin, am I seeing anything? I'm seeming not to see anything right now. There we go. If I push down hard, then we see activity coming out of the equivalent output pin from that chip. And then the other suspect one was DIO8, which is pin 10. We weren't seeing anything at all. We're now seeing a signal coming in, and out of that, I get good connection, we are seeing a signal as well. I've probed all of the other DIO lines on this chip, and they all seem to be working. I've probed all the DIO lines on the other MC3446 that handles the IO lines, and that seems to be working. And I've probed, I think, all of the signals on the MC3446, the transceiver that handles the control lines for the bus. So it's looking healthier. In particular, the signals from this chip are looking healthier. So next thing I'm going to do is reseat the 6532 and put the bent pins back in the board, and we'll see if we see the same signals on this transceiver. 6532 is reinserted with the bent pins reinserted. So if we double check what we're seeing now on this chip, we're still seeing a signal coming in on DIO5, and we're seeing one going out. And on 8, seeing a signal coming in and a signal going out. So that looks promising. Now bear in mind that we do still have the 6532s swapped around from their original position. If, I don't know, I manage to zap this chip or zap the parallel port input with some static, or I managed to short something out previously, then I might not just have toasted this chip, I might have toasted the 6532 that's attached to that chip. That would now be this one, so we would still see errant behavior. But at this point, I'm going to see if the PET can actually properly talk to the disk drive. So I shall kill my program. I shall close the channel, and I shall attempt to deload a file. File not found error. Well, that looks like a better failure than I was seeing before. Let's see if I can get the status from the disk drive. Weird angle to type at. No, I don't think so. We just reset the disk drive. Okay, I have an initialize command ready to run on the PET, and we'll see if actually it manages to talk to the disk drive. I didn't see any activity from the disk drive at all then. So I think we've still got a problem or two. I think it's working. Take a look at this. I reconnected the disk drive to my XUM1541, and I attempted to run the status command here, and the disk drive attempted to, well, it banged its heads. So I'm thinking that it caused it to actually run the initialize command that I tried to send from the PET, which didn't work for some reason. And then you can see I tried to query the status and I got a whole bunch of garbage back. So, okay, I thought maybe I'd done the wrong thing from the PET, right? So I tried running the status command again. And look at this. I got a really weird error from the disk drive. BDEBOB? Well, that looks awfully like read error, doesn't it? Perhaps there's a bit missing. So I pushed the MC3446 better into the socket and ran the status again, and you can see now it seems to be working and giving me a sensible status error. So I'm now going to try and initialize drive 0, which I can do like that. You can almost certainly hear the head banging. So let's stick a disk in, do an initialize, and see what we can see. Okay, let's try a directory listing. Now, just bear in mind, this disk may not have been formatted for the 2040. So that suggests to me that this disk wasn't formatted for the 2040. But I think I'm back to where I was before this disk drive broke, which is fantastic news. I'm really pleased with that. So the next thing I'm going to do is I'm going to get this disk drive back together. I've still got the PCB hanging out, and I'm really worried that I'm going to accidentally short circuit something else. So I'm going to put it back together and then put it through its paces a bit. I've managed to successfully format a disk in drive 0, and I've also managed to read it back in drive 1. So I'm pretty happy that this disk drive is now working just as well as it was before whatever happened to it. In terms of what that was, I suspect that when I had both these two disk drives hooked up at the same time to this ep1741, I managed to short something out on this, or I managed to zap it with static. Obviously the transceiver might just have failed on its own, but it was working one day and then wasn't working after I'd been fiddling around with it. So I suspect it was something that I did. So I should definitely be more careful in future using this and using this 45-year-old disk drive. Now, it's not the last time we're going to see this disk drive on the channel, because I'm still not sure it's working 100%. I'm still seeing some slightly odd behavior from this disk drive, so I'm going to need to take another look at it. In particular, I think we may still have some alignment and or speed issues with these drive mechanisms. The other thing I want to do is I want to get my Rust Linux XUM1541 driver working really well, both with IEEE 488 disk drives like these two, and also with DOS1 disk drives like this one. So if that sounds interesting and fun, I hope to see you in the next episode. Until next time, rock on.